Okay, good afternoon all of you. In today's session, the name of the topic is velocity time graph. Okay, this is the topic in today's session. We are going to do velocity time graphs. Now, the previous session we had done displacement time graphs. Now, velocity time graph, there are two types. One is velocity time graph for uniform velocity, and the other is velocity time graph for uniform acceleration. So these are the two. So why is this the graph for uniform velocity, or rather how do we say that this is the graph for uniform velocity? So you can see that the graph is horizontal, it's a straight line. So that means the velocity is a constant, it is uniform. So this is the graph for uniform velocity. And uniform acceleration, the velocity time graph, you can see that the graph is rising, it's got an incline. So this is uniform acceleration, it is rising uniformly. So these are the two: velocity time graph for uniform velocity, velocity time graph for uniform acceleration. Now, in a velocity time graph, there are two calculations you can do. If you remember when I taught you displacement time graph, so when I did displacement time graph, I told you that the main calculation is that the slope of the graph gives the slope of the graph gives the velocity. In velocity time graph, there are two calculations. One is that the slope gives the acceleration, and the other is that the area gives the displacement. So there are two calculations you can do. So suppose if I take two instants of time and I find this area. So area under the velocity time graph, so this is velocity versus time. So area under velocity time graph will give you the displacement. So that is number one. And the other is the slope. The other is the slope. So change in velocity by time, it gives the slope of the graph, and the slope of the graph is uniform acceleration, right? So I repeat again, change in velocity divided by time is called the slope of the graph, and that is called uniform acceleration. And area under velocity time graph gives the displacement. So these are the two calculations which we can get out of velocity time graph. Area under the graph gives displacement, and change in velocity by time gives the slope. So these are the two calculations we can get out of velocity time graph, right? Now you can see that uniform velocity means it will be horizontal straight line, and uniform acceleration means it will be a straight line with an incline. So horizontal straight line is uniform velocity and incline is uniform acceleration. And of course, the last session I told you displacement time graph for body at rest, body at uniform velocity, and body with uniform acceleration. So based on all these discussions which we have had last day and today, I am giving you a few graphs, and I'll tell you what you have to do. That will be your homework for the next session. Okay, now listen all of you, this is your homework for the next session. So I have given you 6 graphs, 1, 2, 3, 4, 5, 6. So I have given you 6 graphs. So from these 6 graphs, 1, 2, 3, 4, 5, 6, you will have to say for each of these graphs, you will have to say, is it uniform velocity, or is it uniform acceleration, or is it neither? You will have to say. So there are 6 graphs, and for each of them, one of the 3 options will be applicable. Like for each of these 6 graphs, either it will be uniform velocity or uniform acceleration or neither. And you will have to say for each graph out of ABC which one will be applicable. That is what you will have to say. So these are the 6 graphs, and this graph is displacement versus time, this displacement versus time, this is velocity versus time, displacement versus time, displacement versus time. So these are the 6 graphs, and for each of them you have to say whether it is uniform velocity, uniform acceleration or neither. That is your homework, right? So I'll end this session. You have to do the homework by 9 p.m. Monday. Bye all of you.